Good morning, children. You are welcome for the next episode 10. Now, we want to discuss about what are the reasons for scattering and also why the sky appears blue and when sun set and during the sunrise why the sky appears red in color. See, here we are going to do an activity. Here is an activity. In this is a convex lens placed in a lens stand. Convex lens placed in a lens stand. And another, this is a glass tank in which we take 2 liters of water. This is a cardboard. Here we made a hole, and this is a second convex lens that also placed in a lens stand. Then this is a screen. Now see, what we are going to do here is the activity. Why the sky appears blue and also the rising and setting sun appears red in color. That we want to find out, and the reason for it we want to find through an activity. See, this is a convex lens as here, and it is placed in a lens stand. This is a convex lens and it is placed in lens stand here, and then you arrange here on tank, glass tank, and in it take a clear water of 2 liters. Then this is a cardboard with a hole, and here again another convex lens. Now see, from this here arrange a bright light. Here is a, see, you can see through this when we place this you can get see a bright spot on the screen like this. When this source is arranged at the focus of this convex lens, we can see a bright light passing through this one. Here is a bright source of light. From this light is coming, and this bright source of light is at the focus. Where it is at the focus of this convex lens. So light from this becomes what? Parallel. And when this light is allowed to pass through this glass tank and it contains water, this light passes through this, and when this light passes through this, and here this parallel light when falls on this, and it falls on the screen this way. Now we can see whatever the color of light here, that same color we can see here also. Here also no change in color. Now place this light source at the focus of the first convex lens, then we get a bright spot of this light here on the screen. Now add 200 mg of sodium thiosulfate, 200 mg of sodium thiosulfate in this, and add 1 or 2 ml, 1 or 2 ml of concentrated sulfuric acid to this. What are the substance we added here? About 200 milligram of sodium thiosulfate to this water. Now, this sodium thiosulfate, what the substance name? Sodium thiosulfate. Otherwise, it is also called hypo. What is sodium thiosulfate or hypo is added to this one. Then here 1 to 2 ml of concentrated sulfuric acid. Then after 2 or 3 minutes, the material here added sodium thiosulfate and concentrated sulfuric acid. Then 2 to 3 minutes, that means after adding this 2 to 3 minutes after, we can see small particles of sulfur precipitating here. Then we observe the color of this light, that means white light is coming here. That light now become, that means when we observe the 3 sides of the tank, we can see the blue color of the solution. That means we can see the solution is in the blue color. Now, as the time goes on, that means when we observe from the 4th side, when we observe the light from the 4th side, we can see orange red light at first. What light? Orange red light we can see on the screen. That means the light from the 4th side coming to the screen, we can observe what color? Orange red color. After some time, that is here the sulfur particles formed, that is smaller particles combined and it becomes larger particles. Then the longer wavelength light such as red also scattering. So we can see after some time crimson red color. What color then we observe? Crimson red color. At first we observe on the screen but orange red color. Then we can see what color? After some time crimson red color. That means a deep red color. Deep red we can observe. This shows or this activity help us to find the blue color of the sky and also why the rising and setting sun appears red in color. For that, at first here the sulfur particles are smaller, so we get a shorter wavelength light is scattered. Because of that, we got blue color. After some time, the smaller particles combines to form larger particles. We get what color light? Crimson red color. From this activity, we can find why the sky, that means clear sky appears blue and rising and setting sun appears red in color. See the material here we used, which are the materials used on hypo Otherwise it is called sodium thiosulfate. Sodium thiosulfate. Second, we add concentrated sulfuric acid. The material required or the material we used in our activity, once again remember, which are on sodium thiosulfate. What is the name of the substance? Sodium thiosulfate, a chemical. Then concentrated sulfuric acid. Then one question, what color did you observe? What color did you observe from the three sides of the tank after 2-3 minutes? Which color you observe? Blue color. Which color? Blue color. Why? Because we know when the reaction between sodium thiosulfate and sulfuric acid, sulfur particle formed. That sulfur particle size, when we compare, it's very small. So shorter wavelength light, blue scattered at first. So that the solution appears blue in color. Then what color do you observe from the fourth side? That means on the screen. At first we observe which color? That means orange, red. Which color is observed from the fourth side at first? Orange, red. Which color? Orange, red is the color you observe. Then after some time, this orange red changed to which color? Can you remember? Which color? That is crimson red. Which color is it? Crimson red. That means a deep red color. Now, why the sky appears blue? Because when light travels shorter distance, that means from the sun, shorter wavelength light such as violet, indigo, blue scattered more than that of other colors. The combined effect of that all we get as blue in color. But during sunset and sunrise, why the sky appears or the sun appears red means at that time sun is at the horizon. Sun is at the horizon, so light want to travel longer distance and thick atmosphere. At that time, longer wavelength light such as red also scattered, and shorter wavelength light such as violet is scattered and violet, indigo, blue scattered and lost. We get that color as red. That is why this, see, you can point out these chemicals used. Then sodium thiosulfate and concentrate. You should remember these two names. Then which is the color you can observe from the three sides of the tank? That is blue. Then at first orange red and crimson red, later we can observe from the fourth side. That also you want to remember. Now these are the things you want to remember from this unit. That is a refraction of light and a colorful well. Now on to questions given here. First one is why do stars tingle? Why do stars tingle? That we know due to the atmospheric refraction. You know why stars tingle? stars tingles due to the atmospheric refraction, and stars that is set very far away from us. So stars we can consider as a point source of light. Second question, 11th one, explain why the planets do not tingle. Planets, when we consider with that of stars, planets are closer to us, and that planets are not a point source of light. Because of that, these planets do not tingle. Why do the sun appear reddish early in the morning? That we know. In the morning, sun is at the horizon. At that time, sunlight travels thick atmosphere, through thick atmosphere, and also to a larger distance when we compare with the other times. So shorter wavelength light at that time scattered and lost. Hence, which color light we get? Which colored light that reaches to our eye? Only longer wavelength light red can reach. That is why the morning sky or sun appears red in color. Next question, why does the sky appear dark instead of blue to an astronaut? Why does the sky appear dark instead of blue to an astronaut? Why? Because in the case of an astronaut, he is in outer space, there is no atmosphere, so no scattering is happening there. Because of that, or because of the absence of scattered light, the sky appears to him as a dark. The same is the case, the sky of the moon also appears dark, because in the moon there is no atmosphere, so sunlight is not scattered there, hence the sky appears dark for the person landing or staying in the moon. Okay, now we can go to next unit. What are the things you want to remember from this unit? What is actually tingling of star, scattering of light, refraction through a prism, then the activity to find scattering and blue and red color of the sky during sunset and sunrise, and why clear sky appears blue. These are the things you want to remember from this unit. Now, next unit is electricity. Now we are going to discuss about the next unit, that is electricity. Now you want to remember what is actually electricity, or what constitute electricity. What constitute electric current or electricity? Then how we can control or regulate? How we can control or regulate this electric current? Then what is the function of a switch? Now we want to find out the answer to these all questions. Actually, how electric current constitute, or how electric current is forming, then how we can control or regulate it, what is the function of a switch, what is an electric current. Now first of all, see what is the function of a switch? Switch is a link between actually a cell and an appliance. For example, when we on the switch, the bulb glow, and when we off the switch, the bulb off. Or switch, when we switch on, the bulb glow, and when we off the switch, bulb does not glow. So here actually switch is actually functioning as a link between this cell and this bulb. In the case of a torch, when we on the switch, the light comes out. When we off the switch, light stop. So here we consider cell, appliance, switch. That is, switch is a link between these two. Switch is a link between these two. Now see, actually what is an electric circuit? We want to know about electric circuit. When we consider a continuous and closed path of electricity, when we consider a continuous and closed path of electricity, that we can consider as an electric circuit. That we can consider as an electric circuit. What is an electric circuit? A continuous and closed path of electric current is called what is electric circuit. A continuous and closed path of electric current is called electric circuit. Now see, why we consider electric current direction from positive to negative. What is actually electric current? First we can discuss about electric current, then we can discuss about why we take the direction of current opposite to the flow of negative charge. See, electric current actually the flow of electric charges. Flow of what is charges. Flow of charges. Let me see here. We know already there are two types of charges. One is electron and another one is proton. Electrons and protons. These are the two type of charges. Electrons with a negative charge, this with a positive charge. Now, flow of charges. Flow of charges is called, that means number of charges crossing over a particular area in unit time is called actually electric current. That is, the number of charge means actually electrons are moving. Actually, which is moving? Electrons are moving. But when we discuss about why the direction of electric current is taken opposite to the flow of electrons, means when we find out electric charge, at that time they were not known about the particles electrons. That means when electricity was discovered, at that time these particle electrons were not known. So the flow of what is charges, that means positive charge, they consider as the electric current. Hence, we took the direction of charge, that means direction of current as the direction of flow of what is positive charge. Why? The direction of flow of positive charge is considered as the direction of current because at that time when they discovered electricity, they were not known about electrons with a negative charge. Actually, electric current is due to the flow of electrons, but they were not known about these particles, so they discovered, so they considered the flow of protons as the or positive charge as the what is constituted flow of positive charge constituted or forming what is electric current. Because of that, the direction of current is taken from positive to negative, just opposite to the flow of negative charge. Actually, the flow of negative charge constitute electric current, but they were not known about that. Now, see what is actually electric current. What is actually electric current? That means a number of charges. Number of charges crossing over a particular cross section. Suppose we consider a conductor, that means a copper wire. We consider a conductor, this is a conductor. Which is that one copper wire. Now see this particular area. Through this area, number of charges crossing in unit time. What is actually unit time? One second. What is actually unit time means 1 second. Number of charges crossing over a particular area or a particular point, that is considered as a electric current. So, electric current we can consider as a rate of flow of charge. Actually, electric current is the rate of flow of charges. Rate of flow of charges. So, what is actually electric current? Electric current is the rate of flow of charges. See, Q charges. Q is the quantity of charges crossing this area in time t. Within time t, then electric current through this point. How we can find electric current through this point? I is equal to Q by T. That means Q charges. Q is the quantity of charge passing through a particular cross section in time t, then current through that conductor I is equal to Q by T. I is equal to Q by T. Now we want to find out what is the unit of this charge. Q is the charge. Unit of charge is coulomb. Unit of charge is coulomb. Which is the unit of charge? Coulomb is the unit of charge. See, and 1 coulomb is equal to 6 into 10 to the power 18 electrons. That is, 1 coulomb charge is the charge of this much electron. That means 6 into 10 to the power 18 electrons. That electrons, how much charge is there? That is 1 coulomb. And charge of 1 electron is equal to 1.6 into 10 to the power minus 19 coulomb. Charge of 1 electron. Charge of 1 electron is equal to 1.6 into 10 raised to minus 19 coulomb. That means charge of 1 electron is equal to 1.6 into 10 raised to minus 19 coulomb. Okay. Now we discuss about what is electric current. What is electric current? The rate of flow of charges. If Q charges crossing over an area in time t, electric current I is equal to Q by T. Here charge, which is the unit of charge, coulomb. Unit of charge is coulomb. 1 coulomb is equal to 6 into 10 raised to 18 electrons charge. 6 into 10 raised to 18 electrons charge. And then charge of 1 electron is equal to 1.6 into 10 raised to minus 19 coulomb. 1.6 into 10 raised to minus 19 coulomb. Now see, we want to find what is the unit of electric current. Unit of electric current. Unit of electric current is ampere. Unit of electric current is ampere. It is in the name of Andre Marie Ampere. It is in the name of the scientist Andre Marie Ampere. Andre Marie Ampere. It is in the name of the scientist Andre Marie Ampere. The unit of electric current is. Now, smaller units of electric current are, one is milliampere. That is 1 milliampere is equal to 10 raised to minus 3 ampere. 1 milliampere is equal to 10 raised to minus 3 ampere. And another one is microampere. Microampere. 1 microampere is equal to 10 raised to minus 6 ampere. 10 raised to minus 6 ampere. Now see, unit of electric current is ampere. And whose name that unit came into known as Andre Marie Ampere. Now, smaller units of electric currents are milliampere. How much is 1 milliampere? 10 raised to minus 3, 10 to the power minus 3 ampere. And another one smaller unit is microampere. 1 micro mu m. That means mu ampere. That means here mu ampere. That means that is equal to 10 raised to minus 6 ampere. Now see, we want to define 1 ampere. We want to define 1 ampere. See, if 1 coulomb charge, suppose we consider a copper wire, and through this cross section, through this particular point, through this particular cross section, if 1 coulomb charge passing in 1 second, then we see that is 1 ampere is equal to 1 coulomb by 1 second. That means 1 coulomb by 1 second. That means if 1 coulomb charge flows through a conductor in 1 second, then the current through it is 1 ampere. Current through it is 1 ampere. This way we can define 1 ampere current. 1 ampere is the current that flows through a conductor if 1 coulomb charge flows through it in 1 second. 1 coulomb charge flows through the conductor in 1 second, then the electric current is 1 ampere. So 1 ampere is equal to 1 coulomb by 1 second. Related to these two questions given to you, see, we know what is this is a battery, this is a bulb, switch. When we switch on this bulb glow, here battery, bulb, switch. Here the switch is on and the bulb glows in this case. Now see, related to this there are two questions given on what does an electric current mean? What does an electric current mean? Electric current is the flow of electric charges. Electric current is the flow of electric charges. Another question, define the unit of current. Define the unit of current. Which is the unit of current? Ampere. How we can define? If 1 coulomb charge flows through a conductor in 1 second, then the current through it is 1 ampere. Then calculate the number of electrons constituting 1 coulomb charge. Calculate the number of electrons constituting 1 coulomb charge. We know 1 coulomb charge is equal to how many electrons? 6 into 10 to the power 18 electrons. This much electrons charge is 1 coulomb. And another question, a current of 0.5 ampere, is drawn by a filament of an electric bulb for 10 minutes. For 10 minutes. 10 minutes. Find the amount of electric charge that flows through the conductor. See, the question is here, a current of 0.5 ampere. 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes. How long? 10 minutes. Find the amount of electric charge that flows through the circuit. See, here given current. Which is the letter used to represent the current? Current is represented with the letter I. I is equal to 0.5 ampere. Time taken T is equal to given 10 minutes. We know time is considered in second in SI unit. So 10 minutes equal to 10 into 60 seconds. Now we know current I is equal to, the relation is I is equal to Q by T. That we know, current charge time relation. I is equal to Q by T. What? You want to find here amount of charge flowing. So from this we get Q is equal to what? I T. Q is equal to I into T. That is equal to I, how much? That is 0.5 into time, that is 10 minutes, that is 10 into 60, how much? That is 600. Now by multiplying 6 and 5 we get 30. 5 times 6 is 30. Then 2 zeros. Here on decimal point that we want to put. So how much we get? That is equal to 300 coulomb. How much we get? 300 coulomb is the charge flowing through it. Now from this, what are the things you want to remember here? What is actually electric current? Electric current is the rate of flow of electric charges. Which are the two charges that we know? One, protons, that is with a positive charge. Another one is electron with a negative charge. Which is the direction of current? Which is the direction of current? Direction of current is taken opposite to the direction of flow of electrons. That means if we consider a circuit as we taken in the previous case, that is here is a cell. This is the positive part, this negative, and this bulb, and here on switch. See here, this is a positive. This is the direction of current. That means from positive. Actually, electrons flows from here to here, but direction of current is taken in this way. That means opposite to the direction of flow of electrons or opposite to the flow of negative charge. Then we discussed the unit of charge coulomb, unit SI unit of time second, then unit of current ampere, smaller units of current such as milliampere and microampere, milliampere and microampere. Now we can discuss about another point. Okay, we discuss about how sky appears blue and what is the reason for rising and setting sun that appears red in color, and also about what constitute electric currents and which is the direction taken to the direction of current, and what is the unit of charge and also unit of electric current, smaller units of current such as milliampere, microampere, and some problems related to this. With this all we can conclude today's class. Okay.